Hey guys, good morning. It's Mr. Garner, and I just wanted to go through experimental research with you guys real quick. Basically, what I really wanted to look at today is, as you see up here, it's going to basically give in a good little discussion on these basic terms here: what the purpose of experimental research is, how it's all set up, what's the structure of it, what are some of the biases that we have to watch out for, and then ultimately, what can we gain from it? Okay, so when we talk about experimental research, we're going to mostly be looking at this slide right here. Okay, so I'm just going to kind of make this full screen here for you. And when we talk about experimental research, you've heard about this since you were little kids with science experiments, but it basically starts out with, as we did before, hypotheses, our if then statement. Okay, if we drink coffee, then it's going to help our test scores, for example. We create those operational definitions as we did in correlational research to precisely define what it is we're measuring. But then we obviously want to try to gain something, some in the sense of causation from this. Okay, we isolate, we control for different variables. Okay, we have our independent variable, which is the if, the beginning part of the statement, that's getting usually some sort of, could be breaking off into some sort of the experiment or the control group, and then we want to look and see if that's going to have some sort of effect in some other area. All right, so when we talk about this, that area that's going to be affected, the then is our dependent variable. All right, that's what we want to go ahead and look to see if that is measured, but also obviously what's the outcome of it, and look to see if that really does go ahead and cause some sort of change in our dependent variable. All right. When we talk about this, we're going to be looking at some of the other points you see there at the bottom. Don't be biased towards your independent variable, and don't give off signals about your bias demand characteristics. So we're going to talk about those a little bit at the end, because these are things we have to watch out for to create a true causational based, experimental based study. If we don't control for these, or if we allow for these to happen, that could cause flaws in our research. Okay, so what we're going to look at, as you see right here, it's a little bit more of a defined graphic, but we see over here with our independent variable, we're going to be talking about random assignment, the control in the experimental group, placebo effect, all that fun stuff you probably remember, and then look to control our confounding variables. Okay, so the purpose of this is to establish a causal relationship, right? Cause and effect. We couldn't do that with correlational between variables. The strength of this is we can find out if one variable or independent causes a change in the other. A good way to remember this is the independent variable is what you do, the dependent variable is what you get, right? But the weakness is we can't control for every single variable possible. So we're going to have confounding variables. There's going to be bias. We have to try to control for them as best we can. All right. Some other terms we want to make sure we're clear with. I'm going to look at the extraneous variable and the confounding variable, but a big term that comes up a lot of times, and it's not even covered in your book, but it's something that they like to drop on the exam once in a while, is a term called the null hypothesis. All right. Now, the null, essentially what it is, it's like a reverse of a hypothesis. What they say is they might say that the consumption of coffee has no effect on test scores. All right, well, that's not written in an if then statement. But what it is, it's written in a negative statement in the sense of the independent has no impact on the dependent. All right. Now, the point of research is to try to disprove this. Okay. At the end of our talk on experimental in the next screencastify, we're going to be looking at inferential stat. And when we have that statistical significance, that statistical number that we're going to look at, that will lead us to hopefully disprove or reject the null hypothesis. So it's a different way it can be phrased, but you want to know exactly what that means because it can sometimes trick some people up. All right. So here we go. Independent, dependent. I've talked about this a little bit already. Independent is what you do. Dependent is what you get. The if, the then. Okay. It's the cause of what you are studying. This is the variable that's manipulated by the experimenter, and it's the variable that you're going to change. So, for example, coffee, the consumption of coffee and the consumption of caffeinated coffee. Be more specific. How many milligrams? How many cups? Our operational definition. We think that's going to have an effect on how you perform on the test. All right. The effect, the result of that caffeine is the test score. It's the variable that's measured by the experimenter. Okay. And it depends on the independent variable. That's a great way to remember it. Okay. So if we think about our independent variables, caffeine, we think about our experimental group, they're going to get caffeine. The control group, as we know on the other slide, is going to get some sort of an idea of maybe decaf coffee, for example. Okay. But in that control group, even though they get the placebo, they get decaf, it's the same cup, the same sugar, the same cream, the same temperature. If not, you have confounding variables. So everything has to be the same. The only thing that can be different that's manipulated in that independent variable group, in that control group, is the fact that you've taken the caffeine out. Okay, so being able to identify your independent, dependent variables is one of the most commonly asked questions on an FRQ and one of the most commonly asked multiple choice questions. So reading this, you should be able to understand that when you read the study program affects graduation rates. Okay, the if and then the then. What follows the if is the independent, what follows the then is the dependent. Typically, they don't write it that way. They're going to write it in this format, and you have to go ahead and figure it out. Okay. Remember, we have to talk about operational definitions. It lets you replicate it, be as specific as you can, and it lets you get a number from one of your variables. Okay. So go through and you can check out these for operational definitions. Okay. Using these control and experimental groups when you're giving treatment. So with drug trials, school programs, to look and see if like a certain level of a course works or a certain study program works, certain food treatments, okay? The experimental will get the treatment and the control group will not get the treatment. And by doing that, you can get a number and then be able to understand if there is some sort of an effect on that dependent variable. So our experimental group, they are the one that gets the change in the independent variable. They're the one that gets the caffeine tablets or they get the caffeinated coffee. But we also know that our mind is very suggestible. You want to be clear with the placebo effect. And that's kind of the point of why we go ahead and give the control group, is because the control group, even though they're getting the coffee without the caffeine, everything's the same. Might the fact that they're drinking coffee, might that have their brain act in a different way and give them that false sense that they actually are being affected by drinking that coffee. So when a person takes a medication that they think will help them, sometimes it actually does work. And you're going to watch this clip. You watch the clip in class about people that take placebos for sometimes medical or psychological conditions. They're told that they're taking a placebo in some cases, but the act of taking the pill, the act of going through that ritual, in some cases lets their brain go ahead and actually sometimes work to solve the problem or alleviate it, because the side effects of the medications can be so bad. Okay, because it's all about expectation. Okay, so you saw the video in class. It's pretty interesting to see, but in some cases, as we know, it's a common phenomenon when we talk about the suggestibility of the human brain. So in some cases, it could be both. It could really be the caffeine, or it could be the placebo that's affecting the test scores. Maybe we don't know. Okay, but either way, we want to try to conduct the research and see if that is ultimately the case. So our control group is not subject to any sort of change. They're given nothing. Nothing special. They're giving the placebo, but they are still taking the same test. They're giving the same amount of sleep, the same amount of study time. We want to look to try to isolate just the caffeine is the only difference between the groups. Okay. All right. Once again, talked about random assignment. Random assignment is for experimental only. Don't be confusing that with random selection or random sampling. It's only for survey research. When we talk about random assignment, involves taking a sample and randomly assigning the participants to either the experimental or the control group. Random assignment only applies to experiments. So getting your name alphabetically, every other name to experimental control, perfect. Random number generator, perfect. Put names in a hat, no, can't do that. Okay, now why we do this? We do this because this controls for confounding variables or random variables. So when we talk about like certain random variables, uncontrolled factors like time of the year, socioeconomic backgrounds, personalities, experiences, stress, these are all things that, in one way or another, random assignment sometimes can control for that, because we are putting each person, giving them an equal chance to go into those different groups. Random assignment controls for those confounding variables. Many times on FRQs, they will ask you to give a couple of ways that you control for like a flawed experiment. And one of the best ways to always correct an experiment is random assignment. Okay. All right. Let's talk about this real quick, because we have to be clear on this. Some of the best ways we can go to protect biases are to use single and double blind studies. Many times in single blind studies, as we'll see, during the experiment, the participant is unaware of the group they are in, either in the control or the experimental. So the person who is actually involved in the study can sometimes hit it with their bias. So in many cases, we're going to look at a term called experimenter bias. This is when, the research sometimes can be conducted to fit the expectation of the observer. So because they know what the experiment or the control group is, in some cases that can affect the outcome. You'll look at the Stanford prison study in a couple of weeks, and that's a great example of how Zimbardo knew what group some of these people were in and tried to put people in the study that would affect and kind of validate his outcome. You can't do that. Okay. And sometimes you're also going to have something called participant bias, where sometimes that conscious or unconscious people will behave in a way that ensures the outcome fits their expectations of the study for whatever the research wants. So we want to try to minimize this. And the best way to do this is to go ahead and conduct these single and double blind studies. In the single blind study, obviously, they're not necessarily aware if they're in the experiment or the control group. And that kind of prevents the people who are participants from behaving in a certain way. On the other hand, as you see here in this graphic, on the other hand, in a double blind study, the doctor, the observer doesn't know, and the people in the study don't know. So this double blind study is the best way that you can knock out participant biases, experimenter biases. They're not going to be aware of what the outcome is. They're not going to know who's in the experiment or the control group, and that's going to eliminate many of those different biases that can affect us and these confounding variables. So as control increases, confounding variables decreases. That's a great negative correlation to know. Variables that a research fails to control for or eliminate is the best way to kind of explain these confounding variables. The only thing that changes the independent variable. If that independent variable is the only thing that changes, then it must be the thing that caused the change. That's what we want to hopefully arrive at the end of the study. Okay? All right. We'll come back and look at demand characteristics here in just a second. We've talked about experimenter biases, the errors in studies that are due to the predisposed notions of the experimenter. So when you think about, like we said in the Stanford Prison Study, when Zimbardo knew that people were going into the experiment or the control group, that had an impact on the outcome of the study. It was a major violation ethics-wise, as you'll see, but also with